Hey guys, welcome back to AlgoYogi. We are doing graph series now, and our next problem in the list is count sub-islands. Let's go to LeetCode and give this problem a read. So you are given two m cross n binary matrices, grid 1 and grid 2, containing only zeros representing water and ones representing land. So we have done a lot of problems like that. So an island is a group of ones connected four directionally, horizontal or vertical, basically left, right, top, bottom. Any cell outside of the grid are considered water. So any cells that is like beyond the bounds of this grid, it's not in the indexes, then it's considered water. So an island in grid 2 is considered a sub-island if there is an island in grid 1 that contains all the cells that make up this island in grid 2. And we need to return the number of islands in grid 2 that are considered sub-islands. Okay, let's understand what the problem is asking us. We have basically two grids, grid 1 and grid 2. So grid 1 and grid 2. These are two grids. We need to return the number of sub-islands from. So basically, what are sub-islands? The island that are present in grid 2, as well as that all the valid ones, basically the land cells of this particular island that exist in grid 2 also are present in grid 1. So basically, well, we know what an island is. We have done the number of island problem already. So let's directly dive into basically the first island of our grid 2. So this is my island. This is one island. If you see right here, this is one island. Now this island has basically 6 cells that are ones. So there are basically 6 pieces of lands that make up this island. Now in order for this island to be a sub-island, all these cells, so this 1, 2, 3, 4, 5 and 6 cells, all of these cells, they need to be present in my grid 1. Are they present? Let's check it out. So if you see right here, let me change the color. So right here, well, these 6, there is one extra land piece in grid 1, but if you see, basically this whole island is present in my grid 1. So that means my count of sub-islands, is now 1. Let's go over to our next island in grid 2. So if you see, the next island is right here. This is another island, but this grid is not present here. So that is why we're not going to consider this. This is not the sub-island. It is an island, but it's not the sub-island that we are trying to count. How about this particular island? This is again one more island. Is this land cell? Because it's an independent island, or I mean, it is an island, that's why it's independent, that's why it's an island. So otherwise, if there was any other piece of land connected to it, that would be part of this island as well. But this is an island itself. Is this particular land cell, this address is present? Yes, it is present in grid 1. So that is why it will also be considered sub-island. So we have seen two sub-islands. So this basically map to this right here. Well, there is one more sub-island here. There is one more island here, and this cell is also present in grid 1. So that is why there is one more sub-island. How about, is there any other island? Yes, there is this island. But if you see right here, well, this particular land cell is present. But both of these they are not present. Basically, these two land cells are not present. There is water that exists there. So that is why this is not a sub-island. So there are basically 3 sub-islands that we will be returning. So now we understand the problem. How are we going to work on it? Well. There are 2 ways. One is BFS, another is DFS. Anyone can solve this problem. What we will be doing, we're gonna go through all the lands, all the islands in my grid 2, and at this, when you are visiting this island, when you're visiting, let's say, all the cells of this island, so the way we explore an island is we'll be doing using DFS. So first we'll be starting our traversal right here on our first cell of this grid. So if you say 0 1 2 3 4 0 1 2 3 4, so that this is where I will be starting my search. So if I see a 1, that means it could be it's going to be an island, or it could be a potential sub island. So what I'll do is I'll start my DFS. While I'll be doing my DFS, what I'm going to do is, at the same time when I'm exploring this island, I will also check that this particular grid right here, this is also present in my grid 1. This particular cell is also present in my grid 1, and that I will be doing basically when I check for the bounds. If those bounds do not satisfy basically the land condition, then we don't have to return false, but basically have to check if it's a valid cell and it's land, then it has to be present in grid 1 as well. So what will happen is we will have, let's write the pseudocode right here. That will make things really easy for us. So we will have basically, let's say there are R number of rows, C number of columns, and there is a visit set. These are all the variables that we will need now. So I will start my search, and then also the count sub islands. That was or we can even make it short. Count. Just count. Okay, just count. So for I in range, let's say R, for J in range, all the columns, if grid at I and J basically equals to 1, and this I and J not in visit, we have not visited it, not in visit, then what we are going to do is there is one more thing. Another thing is that okay, if this is the thing, then we are going to call DFS, and if DFS at this I and J returns true, then count will be incremented by 1. So this DFS, what this DFS will be doing is basically first checking for the island, that this island, exploring the whole island, and while exploring the island we will add the condition that if it's seeing a 1, first we will ignore all the cases where it's out of bounds, or it's seeing water, or it's already been visited, that cell. If it's seeing basically a 1, that means that 1 has to be present in my cell 1 as well. So this is DFS is basically the main function of this algorithm, solving this problem. So what we'll have is this small function def DFS. I'm writing the Python code, pseudocode I'm calling it, but like Python language itself is very similar to pseudocode. Okay, it translates very well from English to Python. That's what I'm trying to say. So let's call it row and column, and then now we'll have our condition. So if this row is basically less than 0, and I'm going to write these conditions just like that with the comma, but we'll have to write using or. So if this is less than 0, or row is equals to R, or C is equals to column, and then if R and C in visit, they have already been visited, or this grid R and C equals to 0. If this is the case, that means now we return true because it's not like, although it's like going out of bounds or it's water, but it's not dissatisfying the condition that this particular cell that has 1 is not present in my grid 1. Basically that 1 is not present in my grid 1, so it's not basically disqualifying us. So we'll return true from here. So we return true. Now we only go forward if you are seeing a 1. So while exploring the island, you are going to see a 1 because we have already discarded all these other, out of bounds and water conditions and present already visited or it's water. So now it's going to be equal to 1. So what we're going to do is let's store this into result, this variable. Result is going to be if this grid 1 now. By the way, here we were doing all this thing that we were doing is on grid 2. I should have mentioned that grid 2. So here also grid 2. Now the grid 1 at this particular position where we are just seeing a 1 in grid 1. If this is let's write it here. If this is basically if this is equals to 1. So that will store a true value if it is that 1 is present in grid 1 and false if it's not present over there. Now what we'll do is what we can do is first thing I just want to write it like all of it together. It's already done pretty much. So oh my god. Okay, awesome. So that we can actually see everything right there. Okay, so what do we do now? Now this result is going to be true if that 1 is present, and that's what we want this to be counted, for this DFS to return true. But like that's not alone should be the reason to return true. We also have to explore the entire island. In order to explore the entire island and all the grid basically that island contains have to be present in my grid 1. So what I'll do is I will basically, there is a way of exploring all of them. So what I'll do is like this res is going to be equals to, I'm sure you have explored this way. So for dr and dc in basically 1 0 negative 1 0 0 negative 1 0 positive 1. So I'm sure you must have explored this way of exploring all the sides. So what we'll do is this result and what else, the DFS on all of these. So dr plus r and dc plus c, and then finally we return our result. That should return a result. So that is the entire pseudocode. Now let's convert it. So it will be of time complexity big of n cross m, where this is the size of the matrix, and its space complexity is going to be also n cross m. And the reason is like at most we are exploring we are visiting all the cells by one, basically once. Since we have this visit set, and also I forgot to add this, this is right here, we can add this particular value r and c to visit set. Okay, so that basically here we are not visiting it again and again. So like we don't want to like if one of the island has explored like a lot of the cells, then you want to put those cells into visit. Okay, it's going to be a long video. I'm just going to quickly now write the code. It's more important to basically go through the concepts in detail, and then coding this part you should be doing yourself, because that's what really building concept is all about, like translating those your solution approach to the code. This will really help you. Okay, so row and column and visit set now are going to be length grid, then it's going to be length grid at 0, then it's going to be basically set. That's it. Now what do? We're going to have basically, let's write this right here so that we can write the this helper function later. So for I in range R, for J in range columns, if basically this grid 2, by the way I just wrote grid, so both grids are going to be same, so we can just write anything, grid 1, grid 2, okay, or maybe grid, let's do grid 2. Alright, so if grid 2 at I and j is equals to 1, right, those are the numbers that it's storing, so integer numbers, and this I and j not in visit, this is not in visit, and DFS returns true. So DFS will be taking this I and j because it's a 1, so you want to start exploring that sub island. So what I'll do is like sub island count is going to be initially 0, and then we can increment it by 1. Now what do we do? Let's write down our this inner function, helper function DFS, and before we do that I would just like to finally return our answer. Alright, clear, sweet code. Now what do? We have the row and column, so let's write those out of bounds, water, already visited conditions, and just return true from there, because that doesn't disqualify us from a cell not being matched if it's 1 into grid 1. Okay, so what do? If r is less than 0, or c is less than 0, or r is equals to basically capital R, or c is equals to capital C, or r and c not in visit, or it's water. So grid 2 at R and C, basically row and column, is equals to 0. So that means it's water. If this is the case, then we simply return true. Otherwise, what do? This is a 1 now, and result is going to be equal to, well, this particular cell that we are now exploring has to have 1 in basically grid 1 as well. If it doesn't, then the answer will be false here itself, but we'll cover the other scenarios where we are trying to explore the entire island. So here we'll have just like if grid 2 at R row and column, this row and column is basically equals to 1, and now for dr and dc in basically all this 1, 0, so like I'm exploring all the direction. This is basically going down, 1 row down, then 1 row up, and then same way for the columns. So row remains same, then increment the column, so going right and then going left, so 0, -1. Okay, you can even store these into like direction array and then use that here, right? But that for me is gonna like take the entire code out of the line, the view, basically, not the line. So what I'll do right here is result equals to is going to be basically, I'm going to call DFS on dr plus the r that we were already exploring, the current cell that you're exploring. So you're trying to go to left, right, so horizontally or vertically the neighbors. So dc plus c, and then finally you return basically your result. Okay, so that is it. Look at the code. This is really sweet, nice code, and I'm gonna just zoom out so now you can see the nice and view entire screen. Now let's run the code, because I guess we have done everything else. So let's run the code and see if we missed anything. Okay, so we forgot to add the row and column to our visit set. That was our first mistake. Then this has to be the one that you're checking. I think I had it in my mind basically, but I don't know why I wrote it grid 2. But then also here, yeah, it doesn't have to be not because you're checking like basically if it has been visited. It's not like not has been visited. So I think that was all. I guess like now let's try to run it again. Probably this time we don't have any mistake, and yes, we don't. Okay, so now that's a nice little sweet code, and let's submit it. Yeah, I mean, easy to make mistakes. Let's write down our time complexity. Time complexity is going to be big of n cross m, and then our space complexity is going to be big of n cross m as well. And you very well know why, because at max we are visiting all the nodes of our one grid, or like just the size of one grid, and then we're also taking about this like this much of space. When you are basically adding everything to visit, there might be just max, so there could be all of them could be part of the island, and we'll be adding it to the visit set. Yeah. Okay, so now we're done. Let's go back to AlgoYogi, mark this problem solved. See you guys later in the next problem. Bye bye.